Hello guys, it's JohnnyTime and welcome to another smart contract hacking tutorial. Today we're gonna solve the 11th challenge in damn Vulnerable DeFi version 3, which is the backdoor challenge. This is going to be super interesting and fun challenge, and I assure you this is the best walkthrough and best video tutorial that you could find in order to understand finally how to solve this challenge, because it's not that simple, and I hope that in this video I will be able to simplify the solution and the way it works for you. So without further ado, let's get started. Well, this is the 11th challenge, backdoor. To incentivize the creation of more secure wallets in their team, someone has deployed a registry of Gnosis Safe wallets. If you're not familiar, what is Gnosis Safe? It's a multi-sig wallet, which means that you can create a wallet, which is actually a smart contract. Then you can define multiple owners for this wallet and say that in order to execute a transaction, out of these 3 owners, for instance, 2 need to approve the transaction. So it means that it's going to be 2 out of 3. And this way you can have more secure wallets rather than just normal MetaMask or Ledger or EOA accounts, because you need multiple approvals in order to send transactions. And by the way, a lot of DeFi protocols use Gnosis Safe wallets. So the team want to incentivize more people to open these wallets because they are safer, and therefore when someone in the team deploys and registers a new Gnosis Safe wallet, they will earn 10 DVT tokens in order to incentivize them to use Gnosis. To make sure everything is safe and sound, the registry tightly integrates with the legitimate Gnosis Safe proxy factory and has some additional safety checks. So in order to create a Gnosis Safe wallet, you usually go through the factory smart contract, which allows you to create those new wallets, and they create some kind of a contract wallet registry that can integrate with this factory to see when someone actually creates a legitimate Gnosis Safe. Currently, there are 4 people registered as beneficiaries: Alice, Bob, Charlie, and David. So we have a whitelist of 4 users, 4 accounts, which can make those safe wallets. Not anyone can create those wallets and get this prize or bounty. The registry has 40 DVD tokens in balance to be distributed among them. So 10 for each. And your goal is to take all funds from the registry in a single transaction. This is pretty exciting. So we have a whitelist of people that can create those safes, which is obviously not us, because we're going to be the player account if you're familiar with the previous exercises. But somehow we need to overcome this obstacle and make sure that we earn all these DVT reward tokens. So let's head over into the smart contracts folder. So if we go to contracts under backdoor, we have only one smart contract, WalletRegistry.sol. This is the wallet that's supposed to have those DVT tokens and send them once it gets some kind of event or some kind of notification. The new safe was created by one of these 4 beneficiaries. So it imports some libraries ownable from Solidity, Safe Transfer Lib, interface for ERC20 tokens, and it imports Gnosis Safe and iProxy creation callback, some kind of interface to maybe detect a callback from the factory. And the Gnosis Safe, we'll see in a moment why it deploys that. So this is the wallet registry factory, wallet registry contract, and we can see that the safe that will be deployed is supposed to have probably 1 owner and 1 threshold, which means there should be just safe with 1 owner and 1 threshold, so just 1 out of 1 signs. So if it would be 3 owners and 2 threshold, it means that the safe should have 3 owners, and in order to execute a transaction, you need at least 2 of the owners to approve it. So this is the threshold variable. The payment amount is 10 Ether, not really Ether, just DVD tokens. And here they define some addresses and ERC20 tokens. So master copy, wallet factory, and token. I assume the master copy is kind of the template of the Gnosis Safe. So to make sure that you really deploy the right code for the safe. The wallet factory is the factory smart contract from Gnosis, and the token is the DVD tokens that will be sent as reward. Here we save the beneficiaries, all the users that are allowed to create those safes and get the reward. And wallet, so probably after they create a wallet and we validated that it's legit and safe, we're gonna store it here probably in the wallets mapping. Here we define some errors. We will see them in a second. We initiate through the constructor the wallet registry contract. We send the master copy address, the factory address, token, and the initial beneficiaries. And we simply just gonna initialize the owner as the message sender and set all the state variables that we saw here on the top. We're just gonna set them here in the constructor. Here we have only owner admin function that can add new beneficiaries. So if they want to change and add more beneficiaries or incentivize more people to create safes, they can do that by using this function. And here we have the proxy created function. And I think this is not the last function. We have also this one, get fallback manager, but this is the main function. So this is the function that's supposed to be triggered when a safe was created. And let's see what it does. So it's an external function. Anyone can call this. It first makes sure that it has enough DVD tokens in the contract to pay the bounty. If not, it will revert with not enough funds. Then it's gonna define the proxy address. So we do not deploy anytime the whole Gnosis Safe bytecode, the whole implementation, but we deploy a very lightweight proxy contract that points to the master copy, to the implementation of the safe functionality in order to save guys. This is the way it works. So when you deploy a new Gnosis Safe, you don't deploy the whole code, the whole logic, but just a proxy that points to the logic. Now, again, if you don't understand what are proxies and how they work, and you really want to increase your advanced level of smart contract security and smart contract hacking, you can definitely check out the complete practical smart contract hacking course, where we cover so many subjects like this tutorial, but more in depth and more structured. So one of the chapters is going to be call attacks, where we talk of all kind of proxies, how smart contract proxies works, different proxy patterns, transparent upgradable, UUPS, diamond proxies, all these kind of things we're gonna deep dive, and many more subjects. So it's gonna be an awesome experience and opportunity for you, and you're gonna join an awesome Discord community with more students. You're gonna have a final exam with certificate that might help you land your first Web3 security researcher job. So definitely check out the link in the description below if you want to take your smart contract security skills to the next level. The next thing we check is that the message sender that calls this function is the wallet factory. So only the wallet factory, the Gnosis wallet factory, can trigger this function. We cannot just call it from our EOA account and tell it, the contract, that we created a new proxy. No, we have this kind of sanity check. And we also check that the singleton is the master copy. So we cannot just deploy whatever implementation we want for our safe. It needs to be precisely the master copy that is being set upon construction, the legitimate implementation for Gnosis Safe. And here they also ensure that basically after we deploy the safe, we initialize it. You see, we extract the 4 bytes from the initializer parameter for this callback. Here we get the initializer and we extract it. And we want to make sure that we trigger the setup function in the Gnosis Safe. We have a setup function that the wallet properly set up. We will get into how the factory works, how the Gnosis Safe works, because we need to do it in order to understand how the whole process works. And here, we make sure that we have the expected thresholds and expected owners amount. And obviously here, we're gonna take all the owners of the smart contract. We're supposed to have only one owner. So we take only the owner at place 0, and we make sure that he is inside the beneficiaries. So if we just another user that is not in the whitelist of Alice, Bob, whatever, and we try to create a wallet and trigger this callback function, and we are not in this beneficiaries mapping, this will be reverted. Then we get some kind of fallback manager. Okay, I don't know what it means at the moment, but this function retrieves some kind of storage variable, right? from the wallet, the fallback manager, and we make sure that we have a fallback manager. Okay, if we don't have a fallback manager, we revert, and then we remove the beneficiaries because we already we're supposed to receive the DVD tokens. We don't want the same guy to receive it twice, and we register the new wallet in the wallet's mapping. Then we're going to transfer the DVD tokens from this address to the new wallet address, to the new Gnosis Safe proxy. So we don't send it to the beneficiary, to the new account, but we send it actually to his new safe. So he will hopefully, will use the safe to withdraw those tokens or maybe keep them, whatever. So we send it to the proxy, to the wallet address, which is the proxy of the Gnosis Safe, and it's going to be 10 DVD tokens. Well, this is pretty cool. Now we can jump and head over to the test file and go to the backdoor test file. And here we see everything that was described in the exercise description. We have in total 40 DVD tokens. Here we have all the accounts and the variables. Here we have all the signers, deployer, 4 beneficiaries, and player. These are the users array. Obviously, we, the player, unfortunately, are not in the users array. Here we deploy the master copy, the wallet factory, and the token contract. Now we deploy the wallet registry. So this kind of smart contract with all the constructor parameters that we deployed here earlier on. And we expect the owner to be the deployer. Then we iterate every user and we add him as beneficiary. So we do send them in the constructor, and we just check here that every user is registered as beneficiary. Then we send the 40 precious DVD tokens that we want to achieve. Here we have to execute our exploit, and eventually we're supposed to do everything in one transaction, and the users must register all their wallets. They are not supposed to be beneficiaries anymore because we removed them, if you remember, here in the proxy created function. And guys, look at this pretty beautiful line of code. We, the player, are supposed to have all the 40 DVD tokens. So we somehow need to either initialize the wallets for the users and steal those DVD tokens. Now, how the hell we're gonna do it? We don't have any idea at the moment because it's not very straightforward. In order to understand, we really need to deep dive of how the factory works and the safe creation works. We already know that we cannot mess up with the safe implementation because we make sure that the singleton is the master copy. So we cannot set whatever implementation we want. We need to use the legitimate Gnosis Safe implementation. If this check wasn't in place, maybe we could create some kind of malicious implementation that gives the control of the safe to us, or maybe some kind of backdoor that we can set inside, but that's not the case. And also, we know that we cannot create the wallet from our account. We need the beneficiary to be one of the whitelist, and we already saw that we unfortunately not in this whitelist. We have Alice, Bob, Charlie, and David. So how the hell we're supposed to solve this exercise? It's not easy, but we will get into it. This is the time to deep dive even further and activate our attacker mindset. And again, if you find it frustrating and still hard to go deeper and activate the creativity and the attacker mindset, the smart contract hacking course is going to be right for you, and it's going to develop this muscle memory and muscle in order to really think creativity in a creative way, deep dive into the contracts and how they work and different DeFi protocols, and find those vulnerabilities and obviously eventually create those POCs. So the next thing I want to do is to see how this proxy created function is being initiated. It's supposed to be some kind of callback. We have here also a notice function executed when user creates Gnosis Safe wallet via Gnosis Safe proxy factory, create proxy with callback, setting the registry address as the callback. So the factory is supposed to call this function. Obviously, the next thing I want to take a look at is the Gnosis Safe factory. So I will just jump into factory, Gnosis Safe proxy factory. This is the factory contract which we can use to deploy new safes. We have different functions, create proxy, blah, 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 blah. We need the one with the callback. So this one creates proxy with a callback. So we send the singleton, the implementation. The initializer, we already saw here that we need the initializer to exist, and we need to create the selector. We should trigger the setup function in the Gnosis Safe in the initializer. So we need to set up the wallet through the initializer. We have some kind of salt, and a callback. Cool. The callback should be the wallet registry, right? So this callback will be issued and triggered right after we create the Gnosis Safe. And we can see it here. We create some kind of salt nonce with callback. Then we create the proxy. This function is supposed to create the proxy with the nonce and the salt. We get a proxy address and we trigger if we send the callback, right? If it's not address 0, then we execute the proxy created function, which we have here on the wallet registry. So we need to use this function in order to deploy proxies for the users. But if we deploy proxies on behalf of the users, the tokens will be sent to the safe, and we do not possess access to the safe because it has only one owner, which is the user. So it's not going to be enough just deploy proxies for the users, because once it will work, okay, we will go here and then the tokens will be sent to the safe, and then what? It will be stuck in the safe because we don't possess the owner's account. We don't possess Alice, Bob, Charlie, and David. We need to find some creative solution to hack it other way. Well, we need to find another way to execute some kind of code or add ourselves as owners, or I don't know. It's pretty complicated. So we want to deep dive into how the setup of the Gnosis Safe works. Maybe we'll find somewhere there that it will allow us to add some kind of extra malicious functionality. The exercise is called backdoor, so maybe we can insert some kind of backdoor. So the next thing I want to do is jump into the actual Gnosis Safe contract, okay? So this is the actual implementation of the master copy of the Gnosis Safe contract. And this is the setup function, guys. This is the function that we are supposed to trigger after creating the safe, because if we don't do so, guys, look what happens here. We will revert with invalid initialization. So right after deploying the safe, we're supposed to trigger this setup. How we do it? We pass bytes of the initializer and create proxy with nonce. This function will be executed. Create proxy with nonce. And this function, as you can see, it first deploys the proxy and then it checks if the initializer length is greater than 0. It makes a low-level call to execute the initializer in the proxy. So it initializes the proxy by running whatever function we want. And we need to trigger the setup function because this is the requirement for the wallet registry. Now let's take a look at the setup function and let's see how it works. So the setup function receives the owner's array of addresses. It receives a threshold, which is the minimum amount of owners need to sign a transaction for it to work. It has a to address, a bytes data address. This is the fallback handler that we saw earlier on. Maybe we can do something with the fallback handler. Maybe with this data over here, we will see in a second. Payment token, payment, and payment receiver. So it has a lot of variables, and what it does, it first set up the owners. We already saw that we cannot mess up with the owners because we need supposed to be only one owner, which is the beneficiary. And then it sets the fallback manager. Maybe we can do something with this fallback manager, I'm not sure. And then it does something, setup modules. Let's see what it does. It passes the to and the data. As setup owners can only be called if the contract has not been initialized. We don't need a check for setup modules. So it calls these setup modules. What the hell is setup modules with to and data? We don't know. We want to search. We want to deep dive further. Guys, this is our work as smart contract security researchers, to really understand how things works behind the scenes. So what the hell is setup modules? I'm going to search it here. I don't find it here. It's probably in another file. Here we have module manager. I assume it's inside module manager because it's setup modules. So let's go to contracts, base, module manager, setup modules. Here we go. It receives to and data. And what it does, it calls an execute function, okay, with 2, 0, data, delegate call, and gas left. That's interesting. What is execute? Again, it's not here, but we import here executor. So I'm going to open executor, execution, whatever. Let's just open it over here. So this is our executor, and what it does, just execute function. It receives all the parameters and it makes either a delegate call or a call. Now we saw before that we pass the delegate call, right? The enum here. So setup models, it triggers delegate call. Okay, this is interesting, guys. So we can pass, if you think about it, we can pass to the setup function a malicious tool and a malicious data, whatever tool we want and whatever data we want, and we can make the safe execute a delegate call to a contract that we control with the data that we control. This is a big no-no, guys. This is a big risk. Why? Why it's a big risk? Because if you've been through my smart contract hacking course and you know how delegate call works, you know that it executes code in the context of the safe smart contract, right? But it can execute whatever code we want from whatever smart contract we want. So we can provide whatever address we want, whatever contract we want with whatever data. And this proxy safe wallet will trigger a delegate call to this target with this data, which means we can execute whatever code we want on behalf of the newly created safe. Now, this is awesome. Why this is awesome? Because if we can run code on behalf of the safe, we can do all kinds of things. Now, I want you to pause the video, activate your attacker mindset, and try to think what kind of code you want the safe to run in order to hack the safe. So we want to leave some kind of backdoor in the safe, and if you solve the third thing or the fourth challenge, if not, check out my complete playlist, complete tutorial, you know that in ERC20 tokens, we can approve accounts to spend tokens. So we can leave a backdoor in the safe and we can approve our EO account or our malicious contract to spend the DVD tokens on behalf of the safe. Then later on, we can use this allowance in order to steal the DVD tokens from this newly deployed safe. This is pretty genius, and this is the backdoor that I think that we are gonna leave through the setup process of the safe. Now, I know it's a bit overwhelming and hard to grasp at first. That's why I created this diagram here for you. First, before we deep dive into the diagram, I want you to focus on the we can't and we can sections. So we cannot deploy malicious safe implementation because we have the test. We cannot make ourselves owners, but we can make a malicious delegate call or register a malicious module, which is awesome, right? So the way it's gonna work, the attack flow, we're gonna have our attack contract that will initiate a new deploy proxy process. It will call the factory, create proxy with callback, right? This function that we saw. This is step one. Then in step two, the factory contract is going to create a new proxy for a new Gnosis Safe and trigger the setup function because we're going to send some kind of initializable data. The data is not going to be empty. Then the next thing that is going to happen, hey guys, I made a mistake. This is supposed to be step number 4 because in terms of execution flow, and this is going to be step number 3. So once the setup function was executed, then it will make a delegate call to our malicious contract. We're going to make a malicious contract that will have an approve function that will approve ourselves as the spenders. We can spend those DVD tokens on behalf of this Gnosis Safe contract. So this will be executed in the setup phase. Now, once the setup is done, the callback will be triggered from the factory to the wallet registry, and it will execute the proxy created function. In this function, we will go through all the checklist. Everything will be okay. The beneficiaries, the initialize function, the master copy, all the requirements will pass because we didn't do anything wrong. We just registered a malicious module. Don't tell anyone. And then the wallet registry is gonna send the tokens to the Gnosis Safe proxy. Now that this proxy gonna have the tokens, we gonna come later and claim our rights because we made a safe approve us to spend the tokens, so we can come later on and steal the tokens from the safe using the backdoor. We will call the transfer from function to take the tokens from the safe to our smart contract or wallet. Pretty genius, pretty advanced but beautiful attack flow. And again, it's a bit advanced, it's the 11th challenge. Don't expect it to be a walk in the park, but it's definitely, you can follow and understand it and solve it. And now it's time to execute our POC and our exploit. So the first thing I want to do is create our malicious contract. I will call it attack backdoor.sol, and we will just create a simple Solidity file, and let's call a new contract attack backdoor And this is our contract. Very nice, very simple, very easy, right? Now let's define a constructor. And let's plan what we want to do. First, we need to do everything in one transaction, so we will run all the logic in the constructor. The first thing we want to do is create a new safe through the factory, okay? But in order to create this new safe, we will need to work with the factory smart contract, okay? Now, I will not just start to write interfaces for everything. So what I'm gonna do, I'm just gonna import the wallet registry contract, which already has all the functionality of all the other contracts, because it has the Gnosis Safe, it has other things like IRC20. So I'm just gonna import in my malicious contract this wallet registry contract. And we will also have to interact with it. So I'm gonna store its address or its whatever as a state variable. So I will do something like wallet registry. And let's do immutable, private. Let's do private, immutable. And it will be wallet registry. Then we will have to trigger the create proxy with callback function. Now we don't have this contract in the wallet registry, so we'll have to implement the interface ourselves. So I will do something like interface Gnosis factory. And this will be this function that we need to call, right? I will just gonna do it external, and that's it. We have a beautiful interface, and now I can set the state variable Gnosis factory. Let's just copy it. Private, immutable, and it will be a factory. Awesome. Gnosis Safe, we can just define it. Gnosis Safe, private, immutable, and it will be just immutable. It will be just the master copy. This will be the template or the master copy for the Gnosis Safe that we are deploying for every single user. We will also work with the token, so IRC20, private. Why doesn't complete me this tab 9? Whatever. Let's call it token. And what else do we need? Okay, guys, we'll have to create our malicious smart contract that we will use for the callback, right? Because if you remember, we need to create here this malicious approve contract. So let's create it over here, contract malicious approve. And we will just implement the approve function. So function approve, and it will receive the address of the attacker and the token. IRC20 token, it will be public or external. Let's just make it public. And we will just gonna do token.approve attacker. And how many tokens we want to approve? Just all the tokens. So I'm just going to type uint256.max. So basically we will make the safe to do delegate call to this newly created malicious approve function. So it will just trigger this in the context of the new Gnosis Safe, the new proxy, so we can later on access the tokens. It will just, on behalf of the safe, approve our attacker contract to spend all the DVT tokens of the safe. And let's do here also malicious approve, private, immutable, and malicious approve. Awesome, we have all our state variables. Now we're gonna receive here the address of the wallet registry. And we also want to know what are the users that we're going to create wallets for them. So we need to receive it as an address array. Okay, so it will be address memory users, and we will receive the address of the users. And the first thing we want to do is just to store this state variable. So I will do wallet registry equals wallet registry, and we will wrap the wallet registry address, right? So we're gonna do this later. Now, I didn't send all the addresses of the factory, of the copy, the tokens, because we already have them here in the wallet registry as public state variable, so we can just access them from there. So first it will be the master copy. Master copy equals the, we're just going to grab it with Gnosis Safe because it's a type of Gnosis Safe wallet, payable, and this will be WalletRegistry.master copy. Right? We don't need to send it in the constructor since we have here the master copy, we have the factory and the token. I'm going to do the same for the factory. So factory equals iGnosis factory. And the factory, we're just going to take it from the wallet registry. What's the name of the factory? Wallet factory. We have a getter for every public state variable. Let's just change it to factory. And we also can do the same for the token. Token equals IRC20, and it will be WalletRegistry.token. We have a getter for the token as well. Beautiful. Now we need to create a safe for every single user, for every single beneficiary, Alice, Bob, Charlie, whatever. So we need to create some kind of for loop for every user, right? Not only for one user. So I'm going to set up a new for loop here for u_256 I lower than users dot length. If you remember, we passed the users in the constructor. So, and then I++. And now I'm going to iterate every single user. Okay. Now, how the hell we create a new safe? Let's see. So we need to execute this create proxy with callback and pass the parameters. So let's just have here create proxy with callback, and this will be the factory.create proxy with callback. And we need to pass all these parameters, and that's it. And let's see how we pass the parameters. The singleton, we already have it. This is the master copy. So this is pretty easy. The initializer, we need somehow to create an initializer. We will encode it so it will be legit and we'll execute the function that we want with the parameters that we want. Now we don't really care about salt or nonce, so we're just gonna send here 0 because salt nonce is just u_256. We can just send 0, and the callback, which callback we want to trigger, which contract we want to execute after we run the creation of the proxy safe, simply the wallet registry, because we want to make sure after the safe is created, this function is going to be executed in the wallet registry. We already saw it in the factory. So now we need to figure out what the hell is the initializer. The initializer is the thing that will start and create every single safe with the owners, with everything. It's everything that we saw over here. So we can see this is the initializer. And the initializer is gonna trigger the function that we want, the setup function with all the parameters. So let's define here the new bytes of the initializer that we are going to create, memory initializer. And now we're going to build here for every user a different initializer because it's going to be different setup parameters. The first parameter, first we need to make sure that we trigger the setup function. So we're going to do something like initializer equals ABI.encode call. We want to make sure to encode the data and make sure that the selector for the function is going to be the GnosisSafe.setup. This is going to be our function selector, and then we're going to pass all the parameters. So all the parameters are going to be here. So we have first the selector. We want to trigger the setup as the initializer function and all the parameters. Now the first parameter should be an array of owners. Now since we have only one owner, I'm going to define here an array. So address memory owners, and I will call it new address. One item is going to be in this array, and the array of the owners in every iteration is going to be different. So owners is going to be users at I, owners at 0. Only one owner we have in every wallet, so we have the owners is going to be users at I. And then we're going to just put the owners array here as the first parameter. Now the second parameter is the threshold. The threshold is just uint. I'm going to put 1. We need only one account to approve a transaction. It should be the right threshold. Now these are our interesting data, because this is the data that will trigger this malicious module in the setup module functionality, and we want to make sure that this is correct. So the to address is supposed to be our malicious approved smart contract. We already deployed it, or we didn't deploy it, so we have to deploy it, right? So I'm gonna deploy here, deploy malicious backdoor for approve. So let's deploy it, this malicious contract. I will do something malicious approve equals new, and we're just gonna do malicious approve. So we deploy our malicious approve function, and now we can pass its address to the initializer. So it will be address of malicious approve, and the data. What should be the data? We need to make sure that the data will lead to this function, to the approve function. So we need to encode it as well. Therefore, I'm going to do something like mbi.encode call, again, encode call, and I'm going to select the selector. So it's going to be the selector of the function malicious approve.approve, and the parameters. The first parameter is going to be the attacker account, the account that will be able to spend the tokens. I'm going to put this smart contract, so I'll do address this. And the second one is supposed to be the token contract, so I will just send the address of the token contract. So once we do these two things, we are supposed to execute our malicious function on behalf of the safe proxy. Now, all these parameters are not relevant for us. We are not interested in this fallback handle, payment token, payment receiver. So I'm just going to send 0 parameters. So it's just going to be address 0 for the fallback handler, address 0 for the payment token, and I will send 0 for the payment. You see here uint, and payment receiver also address 0, just to make sure to fill all the gaps. And there we go. So we set up our initializer, and this is beautiful. Now we can pass this initializer to the function create proxy with callback, and after the proxy will be created, this initializer will be executed with our malicious backdoor to spend those fancy tokens, right? Now, don't forget this one should be payable, so I'm just going to head here, payable, or it won't compile, I assume. And that's supposed to be good. We have a typo here, so it's factory, and right factory. Yeah, factory. So right after the proxy will be created, this factory function is supposed to return here the address, the proxy address, or the proxy object. Actually, not the address, the object. So now that we have here the wallet. No, we don't have a wallet state variable. So we'll have to create another address, and wallet. And this will be the wallet, the newly created wallet in every iteration. So I'll do wallet equals whatever this factory function returns. And this will be our newly deployed Gnosis wallet. Now, with this wallet, what we want to do, we want to utilize the approval, the allowance, and transfer the tokens from the wallet to the player account, to the EOA account who deployed this smart contract, which is message sender. So I'm just going to do the following simple thing, token.transfer from. I want to transfer from the address. It's actually already address, because once we define it as an address, it's an address. So it will be from wallet to message sender, the one who deployed this malicious smart contract. And how many tokens we want to send? All the tokens. We can just do 10 ether because we already know how many tokens there are, or we can just do token.balance off, use the ERC function balance off of the wallet. So that's supposed to be it, which is beautiful, clean attack exploit POC. This is beautiful, guys. We basically set up all the state variables. We set up our malicious initializer with the malicious delegate call to our malicious approve module over here, and we encode, we prepare this initialized data, we create the proxy with all the right parameters through the factory, and once we planted our backdoor, we can then transfer the tokens from this smart contract to the wallet, basically from the proxy safe directly to the message sender, because we are already approved. Remember, after we initialize the safe, we're gonna call this setup function and set up this module with the to and the data, which is gonna make a delegate call to our malicious approve with this malicious data. This is beautiful, guys. And since we did such a great job, we don't have to do much rather than just deploy this smart contract and let the magic happen. So this is exactly what I'm gonna do right now. So const backdoor attacker and await ethers.get contract factory. Now the contract name is gonna be attack backdoor. So let's just make it the same name just for the sake of it. And the player is gonna be the one who deploys it. And now that we have the factory, now I can just do this dot attacker contract equals await attack backdoor dot deploy. And we're just gonna deploy it with the parameters. So the first parameter is gonna be the wallet registry. We're supposed to have it somewhere here, wallet registry. Yeah, this one. So it will be just WalletRegistry.address. And the second one is just the users array, simply as is. We're just gonna pass all the users, and that's it, guys. We did it. I hope so. We did it. We just deployed the contract. All the logic will be executed, deploying all those safes with our malicious backdoor and steal tokens to the player account. And hopefully all these tests will pass. Now it's the money time and it's time to run the code. Yeah, guys, we have the first error, which is we don't have a comma here. So this is just one comma. And let's try to run it again with fixing the error, the typo. So clear and yarn backdoor and cross your fingers, guys. This is the money time. And what the hell? We have another error. Yeah, we miss a semicolon over here. Let's run it again. Oh, of course. What did you expect? That we'll write it on scratch and it will work from the first time? Yeah, what the hell did I do here? Payable, address 0, it's supposed to be like this. Okay, this looks better, everything looks better. We have semicolons in every line. Let's try again. Yarn backdoor. Yeah, undeclared identifier, this is the next error. So it's instead of user, it's supposed to be users. We don't have user, we only have users. Let's clear the terminal and run the test again. Cross your fingers, guys. Yeah, another, of course, wallet registry. Undeclared identifier, wallet registry. Again, waller instead of wallet. So where is it? Wallet registry. Try again. Yeah, and we don't have a selector with uppercase setup because the setup is lowercase. The function starts with small s, not with big S, right? Dumb s. So this will be just small s. And hopefully, no, work. We have another issue here. Here we expect to get an IRC token and we sent an address. So I'm just gonna change it to token. And let's try to run again. And we have another issue. Okay, so the next issue is that this proxy with callback is supposed to get an address type and not a master copy type. You see, it's an address, so I will send an address. And you know, just small issues, type errors and stuff like that, syntax error that we fix pretty quickly. And hopefully, eventually, the contract will be ready to work. Okay. Yeah, and this one does not return an address. We are not interested in the object. So as you can see, it returns an object of Gnosis Safe. So I'm just gonna cast it here to address, and that's supposed to be good enough. And let's clear and run again after fixing all those issues, guys. This was tiring. And wow, guys, it was hard, but look at this beautiful terminal. We did it. It worked. We were able to exploit all this wallet registry functionality to deploy those safes with our malicious model on behalf of the users and steal their DVD tokens. Now, if you enjoyed this video and it was very valuable and educational for you, please share it with your friend. Like this video, subscribe to the channel for more awesome smart contract hacking tutorials, and let me know what you think in the comments below or what other videos you want me to create. Thank you so much for hopping in and watching and learning with me here in JohnnyTime, and I will see you in the next time. Bye bye.